Now that you learned all of the gas laws, let's practice them. So it's your turn to try this out, and don't worry, we'll go over everything step by step.
Here we go. So, we will start out with, I don't even like, to be honest with you, I don't even like reading these problems because as soon as I read it, I get confused and I start trying to figure out like, what concept is this. I like to just do what you taught me and just pull out the given, pull out the finding. Yeah. You know what I mean? Rather than like trying to get caught up on what it's saying.
I get it. And sometimes it feels like they're telling a story that is just like irrelevant.
Yeah, like, and sometimes it is irrelevant.
Yes,
right.
It is.
Because it doesn't make sense to me, like, logically, so all that really matters is the numbers anyway.
Pretty much. I would say there are, of course, like some things like calorimetry, we saw some words, like absorb or release. That is important. That is important.
And like the word of, yeah. So
exactly.
You gotta look out.
Like little things. But yeah, for the most part.
But I try not to like overanalyze it.
Yes, I agree. Just look at what you're given, what you're finding. Find a formula, plug it in, move on.
All right, so here we go. So it looks like we are given a pressure.
Yes.
Of 100 millimeters of mercury. Mm-hmm. And then, that's P1 then. This must be P2. Okay, and then we're also given V1.
Good.
So,
yep. Mm-hmm.
I know we're going to have to...
Wait, finish the sentence. What is it asking for? And then what is it? It's still giving us more info. Yeah.
Oh. Ooh, it's giving us temperature too.
Mm-hmm.
So, wait, how do I know whether what it's giving me is T1 or T2, or does that matter?
Read the sentence.
What would the final temperature be? So it's giving me T1.
Yes.
I want T2.
It's giving you correct, right? Because it gives us the original.
Melissa, you have to read.
there are certain things, yes, like certain things, like you don't have to know what a piston is. You don't have to know, certain parts of it. But yeah, like final temperature, sure.
Like what? Okay, here we go.
Yeah.
So I'm trying to figure out now. I know I need to convert the temperature to Kelvin. So I'm going to add it to 73. Is that it?
Correct. Yes, that's right.
Okay. All right. So. $363 kelvins. Okay. And then, do I have to convert the millimeters of mercury over to?
You don't. So not for this one. I'd say that's only for the ideal gas law, or if they asked you to. So since both pressures are the same, both volumes are the same, you're good. You converted the temperature, find your formula, and plug it in.
Perfect. Okay. So we're looking for pressure, volume, and temperature. So, okay, so it's this one here.
Yes.
What? Why isn't it letting me copy it?
Because I wrote it.
Oh, yeah.
It's okay. I know, because it's in handwriting.
Yeah,
it's in handwriting.
Like
I know.
It, yeah. Okay. Let's pretend that didn't happen. Okay. All right, I'll just write it out myself then. Okay, so I guess I'll just highlight it then, at least so we know which one we're using.
Yeah. Cool.
So there's that. So we're gonna do our P1, which is this.
Good.
Times V1. Oh, I should have wrote this smaller. Now I see what you go through.
A little bit. Yeah, you're good.
Okay. Over T1 equals P2 Oh, at first I thought I put...
Oh, because they're similar. Yeah, no, they're similar.
Yeah.
Yeah.
Okay, I just, like, don't have enough room for myself here. How come when you do that, it works? And
a lot of practice. I don't know.
I'm just gonna bring this down here.
Okay.
Okay. So there's that. We're multiplying by V2. So 350 over T2, which we're finding.
Good.
Okay. So I will start out over here and I'll multiply these.
Mm-hmm.
So we have 102,000. And I'm still keeping my units right now.
Yes.
And then I'll multiply these.
Good.
Okay. Now, I'm going to multiply both sides by this part, right?
I would say don't do that just yet. So what we would do instead,
divide.
you could actually divide. The left-hand side, right?
Okay.
Or if you didn't like that way, what you could have done is it's kind of like, what is it, crisscross or the butterfly effect, where you multiply everything across from each other, like what is that, 102,000 times T2, and then 363 times 297,000. Well, yeah, you can do that. Like whichever way is easier for you, doesn't matter. Or you can divide the left side. Yeah. Mm-hmm.
Yeah, I think I'll divide the left side.
Okay. That's fine too. You're gonna get the same answer. Yeah.
I have to make all of this smaller because
Okay.
I didn't have enough size. Okay. So that gives me, and I have to keep the entire thing, so.
Yes, unfortunately.
And that's going to be like that?
Yes.
Okay. And then we can
Good. So the next thing is you can't just multiply like 297,000 or 270, a whole number, times each other, because that's not what's going to get rid of it, right? It's actually the opposite. You'd be multiplying by the fraction of itself. So you'd be multiplying by 1 divided by 297. It gets messy, is what I'm saying. So what I would say to do instead is to multiply T2, the denominator, first to both sides, and then deal with it.
divide the other one over.
No. So you're going to multiply T2 to both sides to get rid of it on the denominator.
Right.
So,
and then I'm saying then I'll divide the other side over.
Exactly.
Right, okay.
Exactly.
Okay,
Yeah.
that's way better. Because at first I was like, you didn't have any fractions. Why are you giving me fractions? Okay. So, multiplying.
I'm not evil now. Come on. There are
this
other
is
ways.
Awful.
Why were yours so easy?
Yeah, I'm like, hold on. This is not adding up. Normally we have relatively the same kind of problems. Oh my gosh.
Cool.
Okay.
And then that whole number, I know. Oh gosh. I need to give you more room next time.
My handwriting looks so bad right now. Okay, so now I divide this.
Mm-hmm. Cool. And then, yeah, that's fine. Just put the number. I know the units aren't going to fit, which is fine.
Okay. We know which number it is.
Yes.
So I'll just put the answer up here like you did.
Cool.
So 297. Okay, 500. I'm like having a hard time reading my own handwriting. 0.99175. Okay. Oh, so sig figs though. Hold on here. Oh, am I gonna have to convert it back? By the way.
No. So it's fine that the temperature is in. It didn't specify, honestly. That's a good question.
Can keep it what it was. Yeah, you know what I mean? Because I'm like, well, technically what they gave us was in Celsius, so.
That is true. I'm gonna say let's convert it back. It's a good practice either way. Because they could, Let's convert it back, and that could also help with sig figs.
Oh my gosh, I know. Can you tell that I've struggled with sig figs since the beginning? And I know they're not going to go away, so...
Everyone does. This is
like the hardest concept for me. I don't know why.
I know. In OChem, it's gone. So, I'll tell you that.
Oh, there's something
in OChem, we really don't even do math, so... It's like, yay, but what do you really do?
Yeah, but don't worry about it. Great.
Don't worry about it, no.
Okay, so I need to... So if I'm converting it back to Celsius, then I'm subtracting the
Exactly.
273?
Correct.
Okay.
Good.
Oh my gosh, I just had that number in there and I cleared my calculator.
I was going to say, sometimes when you hit enter, it'll repeat itself, but
Not on this janky thing.
That's right. That's true.
I know. The good days of being able to use a graphing calculator are over for me. Okay. Alright, so now I need to see so I'm going to go ahead and look at this whole thing here for sig figs. Isn't that what you did?
Yes, it is.
Okay. So 3?
Yes.
Okay.
Good.
So we will do 786.
Cool. That's it. And that's in now Celsius since we converted it.
Perfect. Okay. Whew. That wasn't bad. I honestly just struggled with finding room to write. Okay. A gas has a pressure of 0.0370 atmospheres at 50 degrees Celsius. What is the pressure at 0 degrees Celsius? Okay. So we are given pressure of 0.0370 atmospheres, and we're giving T1.
Mm-hmm.
And we're finding P2, I guess?
Good, correct.
Okay.
What else do we have?
Oh, wow. 0.
Yes. Which is?
T2.
Yes, good.
I don't know why I missed that. I'm like, it's 0. It doesn't matter. Okay, so we are fine. We're going to use this one here. The P's and the T's. All right.
Correct.
So let me write small. We're going to do our P1. Over our T1. I guess I didn't need to put that in parentheses.
Now, what do we notice?
Oh, just kidding.
There it is. Yes.
The
Gotta
first
convert
rule
it.
that you told me on the little sticky note.
Really important. Yes. Convert it to Kelvin. Good.
Okay. You somehow had to know I was going to mess that up.
Everyone does. Honestly, everyone forgets after a while.
Wait, so this is 273 kelvins?
Yes. Correct.
Oh.
So it's not really 0. Yeah.
Huh, interesting. Okay. Okay, and then P2 we're finding over T2 is 273 kelvins. Okay, so we will go ahead and divide.
Good. Good.
Okay, and now we will multiply by the P2.
Why the P2?
Isn't that what you said? And then we divide the other one over.
That was when it was on the denominator. So I want you to think we're always trying to get rid of the fraction by multiplying by the denominator each time.
Oh, right. Okay.
Okay. Because it was the opposite last time. Yeah.
Oh, see, I was confused. Okay. All right, so we're going to multiply by our 273.
Good. Yeah. And hey, that's a common thing too. If you're not sure what to multiply, always multiply by the denominator to get rid of the fraction and then continue.
Okay. So 273 times. Okay. Now we have
Good.
Oh, let me bring this down so I might realize. And that is, these cancel, right?
Yes, correct.
Okay, so we're in atmospheres.
Mm-hmm.
And that's it.
And sig figs.
Oh, yeah. 3?
3, correct. Yes.
Okay.
Good.
I'm never sure of myself. But I'm getting kind of better at it. I mean, now that I realize, it just, what confuses me is sometimes we look for sig figs in the original problem, and then other times we're looking at it in our math, and I haven't really distinguished which is which. You know what I mean?
Got it. It's technically both. So it's whatever you're given that you're plugging into the formula or plugging into the math that you're using. Does that make sense?
Okay. And actually what I just said didn't really make sense anyway, because what we use in the problem is what came from it.
Correct. No, but it makes sense. Like what you're saying is, like, let's say if you had like one number that you then converted later to moles or something, and you thought, oh, should I look at the molar mass of it? No, the molar mass didn't come from that. That's already a set number. Okay. You look at, like, that's where I look at, okay, what's the least amount that I used from, you know, you get what I'm saying? So that's why I typically like to, like, it's like safer to say I'm looking at whatever I was given because I'm using that in the math, you know? So. Exactly.
Okay. Yeah. But technically in this instance, at least with these problems, what I'm pulling from the problem is what I'm using, unless we're converting.
Exactly. Unless we're converting. Correct.
Okay. So it makes sense to look at the math. I see what you're saying. Okay. All right. So with 3 sig figs, the leading ones don't count, or do they?
Correct. No, they don't. Leadings don't count. Good.
So 313.
Yes.
0.313.
0.0313. Yes.
Oh yeah, those don't count, but you still have to write them. Yeah.
Yes. We can't change the number entirely, right?
Right. Yeah. We won't be doing that.
We won't be doing that. Good.
Okay. All right, moving on.
That's right. Next one.
Calculate the volume of 7.24 grams of NH3 at 0.724 atmospheres and 37 degrees Celsius.
Yes.
Okay. So we're given 7.24 grams NH3.
Mm-hmm.
Oh, I'm supposed to write it like that's the P.
Good.
This is, hold on, I know this. N. No.
No,
Wait,
it's not.
Which one's the grams?
Exactly. So this is a little bit trickier.
I thought this came from your video because I remember you and I had notes from it, so I thought it came from that.
We'll get to it though, because we can change grams to moles, right? And that's going to give us our N. So this is just an additional step, just in case you see it. Yeah.
Okay, I probably will end up seeing it. So
you probably will. That's why I threw it. Yeah.
Yeah. Okay.
Good. And what are we finding? Okay, perfect. I love that. Yes, just right off the bat, if you see Celsius converted already.
Yeah, just so I don't forget.
Mm-hmm.
Okay, we're finding the volume.
Good. So you were right with the formula, right? You were talking about that. All right, yeah, you're getting there, right? Yeah, exactly. Yeah, you're getting there. Perfect. And then if you want to write what R was again, R was 0.0821. 821, and then liters times atmospheres, all divided by moles Kelvin. Yeah. Cool.
Okay. So we're going to convert that over to moles. So I'll do that first.
Good.
Did you do this in your example problem?
No. Because I was just teaching you the basic formula. I did not. No. But that's why I wanted to do it now together, just so you don't, you're not throwing like a curveball. I'd rather throw you the curveball and work it out together than you see that on your exam alone.
Yes, agree with you, because that sometimes I'm like, wait, but this is not the same as the formula, but it is. You just have to convert. Okay.
Exactly.
So we're going to, oh my gosh, why does it keep, that's the thing about this new Apple Pencil. I do love it, but sometimes it just switches to the eraser.
Huh.
Because you have to double tap to switch it, and sometimes it just accidentally switches. So
I haven't tried the new one. Huh. Yeah.
We are going to have to get our molar mass.
Correct. Yes, you're right.
Yeah.
Bringing back concepts. I know. It's all ties together.
Silliness. I'm just kidding.
Why do classes build off of stuff we are supposed to know? That's not a thing.
What is this?
No.
Okay. NH3. So 14.7. Okay.
Cool. And that's right.
Okay. Do I have to use this whole thing? I do, right?
I know. I'm like, I'm
wondering if it'll alter the answer or not, but we can use the whole thing. I don't care.
I'd say use the whole thing. Just use the whole thing to be safe, since we're round to the very end.
Okay.
Yeah. So those are in moles now. Cool.
Oh yeah. Okay. I'm just gonna put this up here.
Good.
Okay. So now we will do the formula. Mm-hmm. So our P is
good.
V. That's what we're finding.
Mm-hmm.
I know I'm writing tiny. I'm trying to preserve.
It's okay. Room here. You're fine. You're fine. Good. And then the gas constant. Yeah.
Mulk.
Mulk. Yes. You won't forget it now. You won't forget it.
No, I definitely won't.
At first when she said it, I'm like, what are you talking about? And she's like, look, Molk. I'm like, oh, okay, sure.
Look, Molk.
She was very cute. Yeah. Gosh.
Okay.
Cool.
So I'm going to multiply all three of these here, and then I'll divide that over.
Yes. Or, well, not that answer, but the other one.
Yeah,
yes.
this.
Yes. Yes.
0.425.
Good. And I'd say you could even start canceling out some of the units.
Oh, yeah. Like from up top?
Yeah.
Okay, so the moles and the kelvins.
Yes.
So I'm still going to have liters times atmospheres?
Atmospheres, correct.
Okay, now I'll divide.
Good.
I'm going to write the whole thing and then do sig figs.
Go for it.
1, 4. Oh. Okay, so we need, looking at our problem 3?
Almost. 310, how many sig figs are there?
Oh, 2.
2. Yeah.
I forgot. But if there was a decimal, then that 0 would have counted, right?
Correct. If it was like 310.0, then there's 4 sig figs.
Right. Okay.
The decimal.
So 2.
What about the decimal makes it significant? I don't know.
Yeah.
It's just part of the rules. Yeah, I know.
Yeah, the rules that no one argues.
Who made it up?
Okay.
Who knows?
So this becomes 15?
Yes, that's it.
15 liters. Whew. All right.
Awesome. Not bad. So and then this also worked, by the way, because just remembering, that pressure for this ideal gas law had to be in atmospheres. The volume is going to be in liters, just making sure that everything aligns with the gas constant. Just a little side note, there could be a possibility that you might see other gas constants. So there are several, actually there's a lot of gas constants out there that would have different units and different values. Like it would be, I think it's like instead of atmospheres, it's millimeters mercury. Or instead of, millimeters mercury, it's a different atmosphere. It's a different pressure. It's like PSI or whatever. There's different ones. This is the most common one that you typically see. So just in case you do see something different, you're really just aligning all of like the pressure, the volume, and so on to the gas constant that is given. But you're typically you're gonna see this one. Like honestly, this is the most common one I'd say you typically see in college, and then in high school they actually learn everything else. But that's just a side note. Cool. One of the main challenges for gas laws is just remembering all of them. But once you get that down after just repetition, writing them down constantly, and knowing that, hey, when do I have to convert my units? Once you have these two down, it's going to be so much easier to just be able to instantly pick what gas law you need to use.